Hi everyone, today I wanted to go over something that I saw as I was shopping for a new pair of trail runners as it pertains to web performance. So one thing that I might do as I'm shopping for shoes is I'm laying in my bed on my phone and I typically will pull up like a category page on a website. So in this case, we're looking at Hoka first. So I want to explain to you what the bfcache is. And in order to do that, I actually find it's helpful to demonstrate that as opposed to just explaining the technical part. So I'm on the category page, and oftentimes what might happen when shopping for shoes is I click on this first result. I look at the shoe, I see if it's something I'm interested in, and if not, then I use the back button to go back to that same category page I was just on. I'll find another pair later on down the list and say I'll check out this men's Challenger 8. Click on that. Maybe this is what I'm looking for, maybe not, so then I might use the back button yet again to get back to that first page. Now, if you notice here, as I'm navigating back and forth, I want you to pay attention to the fave icon up here. What you'll see is if I click this first result, I'll click on this and you'll see the spinner here. So it's loading, there's network activity, there's activity on the CPU. And if I use the back button, what you'll see is that spinner going yet again. So every time I go forward or back, it sends more activity. There's more network activity going on. So that spinner just keeps going. And this is an example of a page that does not use the bfcache or back forward cache. Let me show you one that does. So on Adidas's website, if I click this first result here, again, we're in the trail running shoe category. It's a very similar page in types of like what type of information is displayed on it. So I click this first result. I'll left click the first result, not right click. So then you'll see that this spinner, it does in fact load. That's to be expected because this is the first time we've looked at this page. If I use the back button, boom, no spin. It is almost instantaneous. If I go forward again, no spin on the fave icon here. You won't see that spinner because this uses that bfcache or back forward cache mechanism. So in terms of what happens from a technical perspective with the back forward cache, it takes a copy of the page and it stores it in memory. So that way there's no activity that needs to happen on the network, and it also reduces what needs to happen on the CPU because it saves the JavaScript heap in memory as well. So we have a saying in web performance that there's two types of limiting factors with web performance. One is that a site is constrained by bandwidth or the network, and two is that it's constrained by the device or the CPU. In the case of back forward cache, what we end up doing is we end up circumventing a lot of that stuff. Now, there's certain reasons that a site is eligible for bfcache versus made not ineligible, as we'll see with the Hoka site here in a second. But it is, from a user perspective, it is a very powerful technique that site owners can make sure that they have enabled, that their site is eligible for the bfcache, because it removes inertia from that conversion funnel. The Adidas site is much easier for me to jump back and forth between shoes and go back to that previous index page that I was on, or this previous listing page of things in that category. Whereas the Hoka page, every time I do it, it has a little bit of inertia because it does need to send things to the network. So let's look at why that is, and I'll show you how to test this to see if your site is eligible for bfcache or not. So in Chrome Developer Tools, if I go to this application panel here, and I go through this list, you'll see a bunch of options here in this panel, and I'll select the one that's under the background services category called back forward cache, and I can test to see if my site is eligible for bfcache. If it is, you'll see a message with this green check mark saying that successfully served from back forward cache. In the instance of Hoka, I'll do the same thing. I'll go to my DevTools, go to Application, find bfcache. I actually ran this before I started the video, but I'll show you yet again here what I end up doing. So the results I get, it tells me not only that this was not served from the bfcache, but also reasons why it wasn't served from the bfcache. In this case, it tells me that pages with a cache control header with a value of no store cannot enter the back forward cache. So what I can do is I can go here and I can look further into this. So I can go, for example, maybe there's multiple ways to do this. Probably the easiest would be to go to the network panel. And I'll just go ahead and I'll clear this out and I will reload the page here. And I'll find my HTML document here. So in this case, it is what's in the URL bar, the mens trail with the query parameter of SZ equals 36. And I can actually go in, this is a fairly recent addition to Chrome developer tools where they have AI debugging things actually enabled inside of the Chrome DevTools. It's very handy if you haven't used it. It is opt-in, so the first time that you try to use some of these AI features it will ask you if you want to turn them on if they're not enabled for you already. So I'll go ahead and I'll click this little caption bubble to debug with AI, and I'll ask a question like, let's see, why isn't this page eligible for back forward, there we go, cache. Can't type today, sorry about that. So it tells me a lot of the similar information here. I'll go ahead and I will make this bigger so it's a little easier to see. So it tells me, for example, that we have this cache control no store on here, and it tells me, for example, most critical reason is that it does have that cache control value. There's actually 3 values in this cache control header, so there's no cache, no store, and must revalidate. The one that's the problem in terms of making sure that our site can be served, or the thing that's making our site ineligible for the back forward cache, is actually just this no store one. So Chrome has done some work to enable sites in some instances to have eligibility for the back forward cache if it has this no store value. However, in the documentation, they do say that it is advised to not use this no store value, because if the no store value is there, the browser only can store things in that back forward cache if it feels it's safe to do so. So by having this no store value there, if you don't need it, which that's something that you would need to test, it might make your site ineligible for that back forward cache. So in terms of, like I said, that conversion funnel, that sales funnel, Hoka is making it a little more difficult than some of their competitors. Again, Adidas has that back forward cache enabled, so it's a little easier to browse around on the Adidas site than the Hoka site. Might that be a purchasing factor in my purchasing decisions? Possibly. So it's reasonable to think that maybe by not having that back forward cache enabled on your site, you might be leaving some money or some conversions on the table. With this too, what I can also do is I can ask, like, what might be a better value for the cache control header? And I can go in and this will give me some examples. So of course it'll tell me what I've already explained here, which is like if you go and you drop that no cache value out of that cache control header, it might make your page eligible for bfcache. Now there's some other reasons why your site might not be eligible for the bfcache, but I think this is a very cool way to go about, one, debugging, and Also, how browsers have put things into the platform or put things into their product to make it easier and faster for everyone to navigate. I hope this was interesting. I hope it was cool to see some of the modern dev tooling, as well as maybe you learned something today. So I hope to see you soon, and thanks for watching.